Hello students, today we are going to solve two problems from Bohr model. So first I will give a brief introduction of Bohr model, then we will go into problems. According to Bohr model, the nucleus is at the center of the atom. It is very small in size and the electron, it will revolve this nucleus in certain definite orbits. Okay, these orbits are also called stationary orbits. Okay, now in order for that electron to remain in this orbit, there is a condition which this model has to satisfy, or this electron has to satisfy. That condition is there has to be an exact balance between the centripetal force and the electrostatic force, which is what? Centripetal force is mv square by r, and the electrostatic force which operates between two charged bodies according to Coulomb's law, the electrostatic force, which is Ze square by r square. Now why this is Ze square by r square? Because according to Coulomb's law, the force is equal to K, which is the proportionality constant in SI, Q1 Q2 divided by r square, which is Q1 is one charge, Q2 is another charge. They are apart by a distance r. Okay, if this holds, then in vacuum this is the Coulomb's law. Coulomb's force is equal to K into Q1 Q2 by r square. Okay, here this is the nucleus. Now we know that nucleus contains protons. If the number of protons are Z, then the total charge in the nucleus is what? Charge of one proton is one electrostatic unit. So charge of Z protons are ZE units. So this is charge of the proton, which is 1Q. Suppose it is Q1. Okay? Clear? Okay. And Q2 here is electron. And the charge of one electron is one electrostatic unit. And the product of these two is Ze square. And suppose they are r distance apart. So the net force is what? Ze square by r square, and it is a proportionality constant. So that's how we arrive at this expression, and this is the centripetal force. Now centripetal force exactly balances the Coulombic attractive force, and from this is one relation, and another relation we get from Bohr model is the quantization condition, okay, which is also called the quantization of angular momentum, which is mvr is equal to nh by 2 pi. This mvr quantity is the angular momentum of the electron which is revolving in the orbit. And n is a positive integer, h is Planck's constant, v is the linear velocity, r is the distance between the nucleus and the electron, and m is the mass of the electron. Okay? So this condition comes from Bohr's postulate. Bohr gave this condition. Okay. From these two conditions, we can solve for R. We can solve for R. And R comes with this expression n square h square by 4 pi square m k z e square. Okay? Okay. Now from here we can see that there are two variables and all the quantities are constants. What are those variables? Variables are n square and z. So all the other quantities like h, 4, pi, m, k, e, these all are constants. And if you put all the values of these constants in SI unit, you will get 0.529, and this is R. So the unit of this whole quantity will come in angstrom. That is, 1 angstrom is 10 to the power minus 10 meter. Okay? Okay? So it will come in meters because it is radius. Radius is length actually. So from Bohr model we can get the value of R, and this is R of nth orbit. Okay? If we want to calculate the radius of the first orbit of hydrogen atom, what will be it? Radius of first orbit of hydrogen atom. Okay? It is equal to, now n is the number of orbit. So 1 square by z is also 1 because it is the number of protons into 0.529 angstrom. Okay? So it is what? 0.529 angstrom. This is the radius of first orbit of hydrogen. It is also called R0. It is also called what? It is R0. Okay. Now that is important for our problem. Okay. And another thing, we can calculate velocity also from these expressions. The velocity takes the expression 2 pi z e square by nh. Okay? And these terms has their own significance. That means that h is also Planck's constant, n is the number of orbit, and z is number of protons, e is electrostatic unit charge, and so on. Okay? And this is the velocity of the electron in nth orbit. Okay. And here also we have two variables which are z and n, and it is 2 pi e square by h, which is, by the way, the constant material here. And if we put all the values in SI, we get this value 2.18 into 10 to the power 6 meter per second. As it is velocity, its unit will be meters per second. Okay. So now, how can we solve this problem? The problem is RH is radius of some orbit which is 0.85 nanometers. Radius of any orbit. We don't know what orbit it is, but it is 0.85 nanometers. Okay. Calculate V. How can we calculate V? So from this expression, that is this, so we know this is R0. So we can write we can write what? We can write R is equal to n square by Z into R0. Into R0. Okay? And now we have to know what is n. What is the orbit? Z is 1. R is 0.85 nanometers. Okay? N squared by 1 into what is the value of R0? The value of R0 is 0.529 angstrom, and we are converting it into nanometers, so 5.29 nanometers. So this cancels, and if we solve for n square, it will come 16. N will be 4. Okay, n will be what? N will be 4. Okay, so calculate V. So what will be the value of V? What will be the value of V? The value of V, now Vn is what? This. Okay, Vn will be this. So V is what? V is Z by N into 2.18 into 10 to the power 6 meter per second. Hence, Z is 1 for hydrogen atom. N is what? It came as 4. So this by 4. And it will be 5.44 into 10 to the power 5 meter per second. This will be the answer. Okay? Is it clear? Is it clear? Okay. So this is one problem. This is a JEE. This problem is a JEE standard problem, and we can solve it by evaluating expressions like that. We can get the value. We can get the expression for V. We can get the expression for R. Like that, we can also get the expression for energy, and we can solve the next problem, which is related to the energy of the electron in the orbit.